This lesson is over the discriminant. The discriminant is something that helps us predict how many x-intercepts a function has. So that's our objective today, is I can predict how many x-intercepts a function has by using the discriminant. Make sure you're reading the daily announcement, checking Canvas messages, and completing your work sessions for all classes, not just mine, and getting caught up on items that you need to get caught up on. Let's go ahead and get started. So the discriminant, what that is, you want to again, you can use your note-taking guide if you'd like. If you don't want to, that's totally fine. But what is the discriminant? The discriminant is a method of determining how many zeros a quadratic equation has prior to solving for those zeros. And I have the quadratic formula on here for a reason, because the discriminant actually is part of the quadratic formula. It's this section of it right here. B squared minus 4ac is part of the formula. So, and again, when we're talking about zeros, we're looking at these three pictures right here. You're trying to predict prior to solving if a quadratic equation has 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. So let's get some practice with that and kind of figuring out possible outcomes of that discriminant. So again, the discriminant is b squared minus 4ac. If the discriminant is positive, a positive number, no matter what it is, if it's a positive number, then the function has 2 x-intercepts, 2 of them. So that picture could look like a few different things. If we draw 2 graphs, we could have a parabola facing downwards with 2 x-intercepts, or we could have a parabola facing upwards with 2 x-intercepts. And of course, there's variations of the two. If the discriminant is negative, that means we have no x-intercepts at all. And these x-intercepts are actually called imaginary, but you'll get to those when you get into Algebra 2, what that means to have imaginary roots. For us right now, we just know if our discriminant is negative, it means we have no x-intercepts at all. So the picture could look like this, or it could open down and look like this. If you get a 0 for your discriminant, so after you do b squared minus 4ac, you have a 0, that means there's 1 x-intercept in that case. And we've looked at some pictures like this before. This is where you have a vertex and an x-intercept that are the same number, or the same point, I should say. So positive discriminant, 2 x-intercepts. Negative discriminant, no x-intercepts. And if the discriminant is 0, there is 1 x-intercept. So let's look at 3 examples to figure out if our quadratic is going to have 0, 1, or 2 x-intercepts. So here we go. So our first thing we're going to do for each one of these is we're going to identify what our A, B, and C are, so we can figure out those values so we can use the discriminant formula. So A in our first example is 9, B is 6, and C is 1. So if we fill in the formula b squared minus 4ac, we would have 6 squared minus 4 times A times C, which is 1. So A was 9, C was 1. So 6 squared, I'm going to simplify as I go along, is 36, minus 4 times 9 is 36, times 1 is 36. So we have 36 minus 36, which is 0. So that means this quadratic formula has 1 x-intercept, just 1. Let's move on to our next one. Here we're going to highlight our A, B, and our C values. A is 2, B is 5, and C is negative 4. So let's use our formula, b squared minus 4ac. Here we'd have b squared, which is 5 squared, minus 4 times A, which is 2, times C, which is negative 4. 5 squared gives us 25, minus, and if you notice, we've got a negative and a negative sign, so those are going to end up making this a positive, so I'm just going to write it right now. We have 4 times 2, which is 8. 8 times negative 4, or I'm going to, again, yeah, we can say negative 4. 8 times negative 4 is negative 32, but we're subtracting that negative 32, so we end up with just a positive 32. Subtracting a negative is the same thing as adding. So 25 plus 32 gives us a 57. That's a positive number, so since our discriminant is positive, that means we're going to have 2 x-intercepts in this case. So we know our parabola is going to cross the axis twice. All right, then let's go to our last one here. Again, let's identify our A, B, and C values. Our A is -2. Our B, a little tricky. Remember, we've got that -1 out front. And our C is also -1. So from here, our B squared minus 4AC, we're going to substitute those values into the equation. We've got, there it goes, okay. We've got -1 squared minus 4 times A, which is -2, times C, which is -1. And again, we want to be really careful when putting these into parentheses because we want to make sure we've got the values and the signs correct, which is really important because I don't want you to miss out on something like that. Okay, so -1 squared gives us +1 minus 4 times -2 is -8 times -1 is +8, but we're subtracting a +8, so we end up with 1 minus 8 here. 1 minus 8, excuse my dog right now, he's barking away. 1 minus 8 gives us -7. Since that answer is negative, our discriminant is negative, that means we have no x-intercepts on this one. None at all. So the reason why we use the discriminant is because it can make a prediction of what sorts of values we have in the future. Like let's say I said, solve this quadratic equation. You could test right away to see if there was actually a solution to what I'm asking you. You could say, oh, let me just quick do the discriminant, b squared minus 4ac. Oh, I got a negative number. That means I'm not going to be able to find any x-intercepts. There aren't any in this case. So for today, your work session is a Canvas quiz. Please take a look at that. And if you have any questions, just shoot me an email, a Canvas message, or we can hop on Microsoft Teams to meet up for some in-person help. Have a great day today, and I will talk to you next time.